Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be creating an auto framing camera. Now on the screen we have a number of objects, and if we grab a hold of our sphere here and we move it to the left, we can see that the camera reacts accordingly. We can do a similar thing with the cube. If we drag this to the right, we get the same result. And if we've got a controller up here, and we've also got a padding control, so we can create close-ups, we can create mid-shots, and we can go all the way and create a long shot, and we still get good framing. Similarly, if we wish to, we can also move our objects up and down, and we get a similar sort of result. It's not 100% perfect, but it works pretty well. So yeah, that's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. We'll start by bringing in a couple of objects. So we'll bring in a cube. We'll make this 40 by 40 by 40. I think that'll do fine. And then we can move it up 20 along its y-axis just so that it sits on the floor. And we'll do the same with a sphere here. We'll bring this in, make it, I think we'll go 15 for the radius, so it's a little bit smaller than the cube, and then move it up 15 so that it sits on the floor with the cube. We'll switch to our top view and we'll think about framing these. So we'll hit H and just zoom out a little bit so that we can see what we're doing. Now the cube here, will set this at a position of 100 along its x-axis, or rather the sphere I should say. The cube will make minus 100. Okay, so they're both set up accordingly. Next, let's just bring in a camera and we'll take a look at what we're doing here. We'll zero it out, and we'll also zero its angles out. But the rotation H here, what I'll do here is make that 180 degrees so that it faces in the opposite direction, and then we can just think about positioning the camera. Let's have a look here. We want to go back into our 3D view, into our object here. We don't want the projection to be top, we want it to be perspective. That's better. Switch back to our top view, so F2 again, and we'll just frame up. So we'll bring the camera until it's just, or this angle here, the field of view is just passing through the center of both objects. And then we'll take a look at what we're actually doing. So if we look at this, here we've actually got a right angle triangle. So that means we can use trigonometry to position the camera, or at least position it along its z-axis. And the way we're going to do that is quite simple actually. If we take the positions of these two objects, so it's at the moment it's minus 100 for the cube. Now we need to absolute that because we can only use positive values here. If we add minus 100 and 100, we get 0. That's no good to us because we want to find this length. So we need to add 100 to 100, divide by 2, we get 100, and that gives us the position of our sphere here. So if we've got 100, and we also know the tangent of this angle, now let's just take a look in our camera's field of view here, the field of view horizontal, 54.4322. If we divide that by 2, we get this angle here. And if we get the tangent of that angle and we divide 100 by the tangent of the angle, that will give us this length. And that's what's going to be important to us. Now, we can see that that's not, if we go back to our 3D view for a second and we look through our camera, we can see the framing isn't absolutely correct yet. But we'll switch back to our top view, so F2 again. But if we add some padding to this and push the camera back a little bit further, we can create the correct framing. So if we added some padding, bring it back to around here, or wherever we wish to put it really, we can see then that we're going to get the correct framing if we just switch back to our 3D view, and there it is. So that's what we're going to be doing here. We're going to be using a relatively simple mathematical formula combined with the trigonometry here, just to actually position the camera and make it frame the objects at all times. Okay, that's what we're going to be about, but how are we going to do this? Well, we're going to be using Expresso and a combination of that and some user data. So the next thing to do is bring in a couple of nulls. We'll rename this one controller and this one Expresso. Add the Expresso tag. And we'll close this down for a second because we're going to do the user data first. So we'll select our controller and then we'll think about doing that next. So with our controller selected, we'll say add user data. And we can think about what we're going to do here. First of all, I'm going to add a group. I'm going to rename it controls and drag it away from our user data here so that we won't see this. I'll also add another group and I'll rename this one objects. Get a hold of my data here and drop it into objects, and we will name this object 1 or object A. Actually, that will do. And the data type will simply be a link. So we'll grab one of those in, and that's fine, that's set up. We can then command drag to copy object A and simply rename it object B. So that's our two objects dealt with. We can then add some more data here and we'll place it so that it's just beneath objects, and this will be called link. Well, it won't be called anything actually. What we'll do is simply remove its name and it will simply be a separator, and we will use a separator line. We can then add some more data, and this we will rename padding, and it will be a float for the data type. The interface will be a float slider, the unit a real value, the step I will say 0.1. We'll start with a minimum value of 400, and 1000 for the max will work perfectly well for us, and we'll just clamp those two values accordingly. We can then hit OK, and we've now got our controls set up and ready to go. The first thing we need to do, because we've got nothing in our fields, we'll drag our cube into object A and our sphere into object B, and they're set up as they need to be. We'll just move this so that we've got nothing orange in there. Otherwise we know that may cause us problems. Right, okay, brilliant. So that's done. The next thing to do is to work with Expresso. So we can open the Expresso editor, just make it a little bit smaller. And now we're ready to start thinking about what we're going to be doing with this. The first thing to do is drag in the controller. And in our controls here, select objects A, object B, and padding. So that's ready to go. Moving on from here, we'll bring in both the cube and the sphere. And at the input stages, we can give them object ports and connect object A to our cube and object B to our sphere. At the output stage, we need to give them position X and position Y. So we'll get those sorted out. And they're ready to go. Brilliant. So those are set up for us. Just drag this down a little bit further. Moving on from here, I will bring in the camera, and we only need to work with the field of view horizontal. That's all we're interested in, because we said that we were interested in this angle, and in fact dividing it by 2 and then finding the tan. So in order to do that, we'll bring in a math node, set its function to divide, and set input 2 to 2, and plumb in the field of view horizontal into input 1. So that's the first step. The next thing is to bring in the all-important trigonometric node. So we'll bring that in, place it here, plumb the output of the divide into the value, and then set the function to tan. So now we've got what we want. We've found half of this angle and we've got the tangent of it. So we're well and truly on the road to getting this working. The next step is to bring two absolute nodes in. So we'll come down to calculate absolute, bring one of those in and copy by command dragging. And we can plumb our position X from the cube and position X from the sphere into the inputs as I've done there. So now, regardless of where we place our cube or our sphere, we'll always be working with positive values along our x-axis, and that's important, as we said earlier. Okay, great. Moving on from here then, we can think about bringing in some more math nodes. So I'll command drag this to copy, and what we need to do is change the function to add and plumb both of the absolutes in here. So we said we would actually add these two together and then divide by 2, and that's the next step. So again, we can copy this divide, so command drag to copy, plumb this in here, and we know that the input 2 is already 2, so that's already set up. So we've added the 2 together and divided by 2. That's the next step. Okay, moving on from here then, we can think about what we're going to do next. Now, we then said after we divided these by 2 so that we get this value here, which is 100, we then said we wanted to divide 100 by the tangent of the angle to get this length here, to give us the length that runs from the center of the camera to here. So that's the next thing to do. So again, we can command drag to copy this divide. We can plumb the output of this one into here and the trigonometrics output into here. And now we've set that up. So this is now generating our length here. So that's all good. Brilliant. So that's the first step. So let's bring the camera in again. And at the input stage, come down to coordinates and we'll give it position Z and plumb this in and we'll see what happens. And straight away, it jumps down to where I had it originally and it's bisecting the two objects perfectly. That's exactly what I said would happen. So that's doing its job absolutely as it needs to, that particular part of the expression. This is all working fine. Brilliant. So the next thing we can worry about then is giving the camera positions X and Y. So let's give position X and position Y. Bring those two in, just open this up a little and then we can reposition them. So we'll just put that above there and that above there, and that's good, they're in the right order. Okay, and then all we've got to do is set these up, and it's really simple to do. All we need to do now is copy this part of the expression twice. So we'll bring that up to there, do the same thing again, and then all we need to do is plumb in our position X into here, our position X from here into here. We're already dividing by 2 because we copied, and that's exactly what we need to do. And then we can plumb this into here. And that sets the camera up at the 0 position between the two objects. So that's always going to remain between the two objects. And we can prove that if we move the cube, we can see that it does exactly what it's supposed to do. So that's working fine. And then finally, we can plumb the outputs of our position Y's into this bottom add and plumb the output of the divide into the position Y there. And that is our expression almost complete. Now, the one thing I did say is that the framing isn't quite right because we need to add some padding. So with our controller here, and in the edit I've actually changed this to 100 because I found that 400 was too big, so I've made our minimum value 100. So if you wish to do that, please do. But anyway, if we move this along a little bit so that we're out of the way, we can grab a hold of a math add. So command drag to copy this one, place it about here. We'll just move this divide down a little bit so that we can place the math add in there. We can then connect the output of the padding here, this padding output can be connected up here. We can connect the divide here, and then the output of the add can be connected here. And we can see straight away the camera has moved, and it's now giving us the padding that we needed in order to make the thing frame correctly. And again, if we go into our 3D view now, we can take a look through the camera. That's what we're now seeing. And we can then adjust the padding so that we can create long shots, mid shots, or just a close-up shot. And we can move our objects and change the actual field of view. That works fine. So it's all working really well. And if we bring this one in here, we can do an extreme close-up of the two of them. And of course, if we move up and down, we change the framing again. And we can use the padding to just help us out a little bit. So yeah, it's all working. And that is how you go about doing it. That's all you need to do to create an auto framing camera. It's mostly add and divide by 2. If you think about it, 4 times we're adding and dividing by 2, or in this case, we're not even adding first, we're just dividing by 2. But that formula, that simple formula of add, divide, and then add, you know, it's just very, very simple. The trigonometric node is doing the complicated stuff. That's just creating the Z position. That's all it does, and you just need that in order to make that work. But that's all there is to it. It's very, very simple. But anyway, that just about brings us to the end of this tutorial, because that's what I wanted to show you, and I've done exactly that. So, as always, I really hope you've enjoyed this tutorial and that you've got some useful information from it that you can perhaps maybe even apply to something else, I don't know. Or maybe you can come up with a way to make the rig even more sophisticated. That's entirely up to you. But yeah, as always, as I say, I really hope you've enjoyed this tutorial. It's been quite fun doing this one. And if you have enjoyed the video, then please give it a like. And if you haven't already subscribed to the channel, then please do so. Leave a comment and, of course, ring the bell. And wherever you happen to be on social media, then please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that about brings the curtain down on this one. So I'll see you very soon on the next tutorial.